In this session, we're going to look at the low voltage wiring on the commercial split systems. 2018 government regulations require at least a 2-speed fan motor on all larger commercial equipment. Here we're looking at our terminal connections. We have our thermostat. We have our outdoor unit, which has the terminals W1, W2, so forth on the main control board, and 2 terminal blocks, TB2 and the VFD, and our air handler on the inside. There is a jumper wire on the outdoor control board between OCC and R. This causes the fan to run constantly. If you want to cycle the fan, you need to remove this wire, or if you're using upper building management controls, you can control it through your scheduling. All of our wiring needs to be 18 gauge thermostat wire for all the 24-volt connections. All the wiring on the commercial split systems goes from the thermostat to the outdoor unit. W1, W2, Y1, G, Y2, R, and common. From the outdoor unit, terminal block 2, we have C to C, G to G1, G1 to G1, 66 and 60, which are auxiliary heat, 66 being the first stage. And on the VFD communications, terminal block TB31 to terminal 1 on the indoor air handler will be all 24-volt regular thermostat wiring. For a VFD, it needs to be 18 gauge 3-conductor shielded cable. Shielded cable conductors will go from VFD, VLT to 2, VFD to 3, and C to 4. The ground shield needs to be grounded to the green screw in the outdoor unit. Depending on the model number of your indoor piece of equipment, you might have solenoids on this. From here, you'll have an S1 and S2 on some units, depending on your model, which are regular 24-volt thermostat wires to control the solenoids. Once we have all the wiring in place, we'll have to go on NL 90, 7.5 ton with a YC or PCO 90. Need to change the settings to 2 stages. To do that, going on the control board in the outdoor unit, we'll use the joystick to scroll down to details, hit enter, scroll down to service, hit enter, scroll down to factory, hit enter and scroll to standard. 5, hit enter and scroll to cooling stages. Now once we hit enter on cooling stages, we can actually get the joystick to the left or right and make it flash. Once it starts flashing, we can use the joystick to left or right to change the number. We need to change it to 2 and hit enter to save. We've now set it for 2 stages of operation. The way we did that was navigate details, service, factory, standard, cooling stages. Now to set the fan control type, we have to do the same thing. Navigate to summary, enter, fan control type, and make sure we are set to fixed variable. Fan control type, again, we can move the joystick to left or right to make the display flash, and then we can make the change and hit enter to save. Once we have it all set up and running, we'll need to set our fan speed by percentage by our pressure drop for the different stages. As listed here, we'll come in and go to commission on the display, hit enter, indoor fan, hit enter. Then we can scroll down to either fan only, first stage cooling, second stage cooling, third and fourth if we have those stages, and the same thing for our heating stages. To actually check the CFM for airflow on the split systems, we'll actually drill 2 holes, 5/16 holes, and we're going to insert an 8-inch piece of tubing into those holes to take a pressure drop across the evaporator coil. This is a dry coil, so we don't want the compressors running at this time. Using an incline manometer, we can check the pressure drop across that coil, and we can use the tables to determine what our CFM is. By this table, we have a 0.026 pressure drop. So we take that across our chart, which is in the install manual. In this case, we're looking at a 180 size. Take our line down, interpolate what airflow is. So here we have approximately 5,750 cubic feet per minute of airflow. We'll need to do this for each stages and set the percentage of command to control the fan speeds.